Hello everybody and welcome to Programming with Chronno, a subsidiary of Learning with Chronno. In this series I will be covering the thought process behind programming, because programming is less about poking at the keyboard and more about the mindset. Today we will be covering tree felling, basically planting trees and chopping them down automatically. I will show an example program that I have created before, and this program is run kind of like this. We have the name of the program, which I just have called new tree. We have the number of trees we want to plant and chop down, the direction we want to dump the items after we chop down the tree, and if necessary, the amount of time that is needed between the trees being chopped down. Now, why would you need that setting? Well, in case you're in a situation similar to mine where you only have a few of a particular type of sapling, and you have to wait until the leaves decay so you can get more saplings. But just for example purposes, I'm going to leave the delay at 0. That way we can just continuously watch this thing do its thing. So this is what happens. The turtle plants the tree, bone meals it, chops it down, and it will dump its items behind it into a chest behind it if you have a chest set up. Now this program will also accept left, right, top, and bottom for places where the chest could be. You just have to tell it left, right, top, or bottom, and it will accept it. So here I have another felling turtle, which we will start to program a simplified version of that program over there. And the first thing we need to do is make sure that our turtle is labeled. And we can tell that just by typing in the commands label space get. And that will get the label if it already has one set. If it does not have one set, we should set the label. That way, anything you program on this turtle will continue with this turtle even if you pick it up and put it somewhere else. And that command is label space set space and then the name that you want this to be. In this case, it's just Chronno Felling 02 because I'm absolutely horrible at thinking up names. But I don't need to worry about that because mine's already labeled. So now, to cut down the tree, we actually have to think about what we're doing first. What is the process that we're going to have to take to plant this tree, make it grow, and then cut it down? Now, we can't just tell the turtle that. It would be simple, but the turtle would have no idea what we're talking about because the turtle isn't as smart as you or I. The turtle doesn't know that it has to take all of these steps to do the simple thing that you just told it to do. But first thing we need to do is tell it to plant the tree. Now, we could either write a program to do this, each individual step at a time, or we can use the Lua command prompt. And you get that just by typing in Lua, L-U-A. And then from here, you can test all of the commands we would use in the program and make sure that they work before we spend all the time writing the program. So, for example, the first thing we need to do is make sure we can plant the tree. So, that command would be turtle.place. And that's literally turtle.place. Open parentheses, close parentheses. Now, this is the basic structure of all functions, as they're called, that we will be using. Turtle is the name of the API that is being called, the Turtle API, and place is the name of the function. And then we have the parentheses to hold any extra arguments that we would use if this particular function accepted arguments, which it does not. So we just leave the open parentheses and close parentheses. And we hit enter. and we can see that it planted the tree. Now the next thing we have to do is tell it to use the bone meal. Well, we can't just tell it turtle.bone meal, that it has no idea what that is. So we have to tell it to place the bone meal. Well, we also have to tell it to select the bone meal first. And that command is turtle.select open parentheses to close parentheses. Now this is the argument I was talking about earlier. So we have the turtle API, the select function, and we're passing it an argument for number 2. And this will select the second slot in the turtle. Now this is 1, 2, 3, 4, 5, 6, 7, 8, the whole way up to 16. So if you want to select slot 16, it's the same command, turtle.select, open parentheses, 16, close parentheses, and it will select that slot there. So now that we have the second slot selected, now we need to place the bone meal. Turtle.place, and we can see that the tree grew. Alright, so now we have the first step. We have the growing of the tree. So let's exit out of here. And let us start programming this function. Edit tree. Now we use the edit command to create the program because we don't have to run a make file command. All we have to do is run edit, and the Turtle OS will create the file for us. So edit space and then the name of the file we want to create, in this case tree, and we will end up with a blank window. And that is basically the Turtle's notepad. Basically, this is where we can type in all the commands that we want to use, and then when we run the program that we create, it will go through from top to bottom all of the commands. So let's put in the commands that we just used. So turtle.place, turtle.select to turtle.place. Now those are the 3 commands that we just used. Now can anybody see why this actually won't work? Aside from the fact that there's actually a tree already in front of the turtle. If you guess that it wouldn't work because we have slot 2 selected, you're absolutely right. Because the last call that we did for a slot was to select slot 2, that's its selected slot. It's not going to reset itself unless we pick up the turtle and put it back down again. So the first thing that we should do, even before the first thing that we had before, is turtle.select 1. And that way we know for sure that it's going to select the slot with the saplings in it before it places the sapling. Now we are assuming that the sapling is going to be in slot number 1 and the bone meal is going to be in slot number 2. Since the turtles have no way of detecting what items are in their slots, we have to assume that the user of this program is going to place them in the slots that we need them to be in. So just for future use, this program, the saplings will always be in slot 1, and the bone meal will always be in slot 2. So now we have a program that once it runs through, we will end up in this situation where we'll have a tree sitting in front of the turtle. And we can test that by simply tearing down the tree we created before, going back into our turtle, hitting Control and then Enter on save, and then Control again and Enter on exit. And then to run the program, we just type in the program's name. So tree. So the first thing we saw it do was select slot 1, plants the tree, select slot 2, uses the bone meal. And we end up with the tree in front of the turtle, exactly like we expected. Now, what do we do after we have the tree? Well, that's easy. We chop out the first block, but then what? Well, I guess technically we could make the turtle go up and then chop out the second block and then make the turtle go up again and chop out the third block. But of course we have these leaves up here, which can cause problems. Because we'd have to move it up, chop it out, and then dig up, and then move up, and then chop out the next block, and so on and so forth. Well, we can't guarantee you how high the leaves are going to be, and we can't guarantee how high the tree is going to be. So we have to do something a little bit different. How about we chop out the first block, and then move the turtle underneath the tree, and then start digging up and then moving up? Well, we can definitely do that. Let's test that by calling our Lua command prompt again. And then the command to chop out the block in front of the turtle is turtle.dig. And we can see it dug out the first block exactly like we expected it to. And then to make it move forward, it's turtle.forward. And there we go. Now the turtle is underneath the floating tree. And then from here, we basically repeat a set of commands. Turtle.dig up, and then turtle.up. So it will dig the block out above it, and then move up. So turtle.dig up, turtle.up. And now we have the turtle one more up below the floating tree. And we could do this again and again and again until we reach the top of the tree. And there we go. That's how we cut down a tree. It is, well, I was about to say it's that simple, but it's not. Because you have to think in a way that humans just aren't used to thinking. For a turtle, you have to tell the turtle each individual step to do a simple thing. Whereas humans, we just kind of infer all the little steps. We do them without even thinking about them. As I said, turtles aren't that smart, so we have to do everything manually. So, let us edit our tree program, and let's add the steps that we just tested. So turtle.dig, and that's to dig the block out in front of it. Turtle.forward, and that's to make the turtle go forward underneath the now floating tree. And then from here, how do we do this? Well, we could count how many blocks up the tree was, and then basically repeat those two commands that number of times. Well, that would work for this tree. So if we type in turtle.dig up, turtle.up 6 times, that will work for any tree that is 6 tall. However, what if you're dealing with one of the fir trees? They're 24 blocks tall. Well, we could program it all in, write it out 24 times, and we'd cover any tree up to 24 blocks tall. But what about the trees that are smaller than that? It's waste of cycles to make the turtle go the whole way up and then the whole way back down for every single tree we use. Well, in that situation, let's actually think kind of like a human would think. So when we dig out the tree and then end our process, basically, we dig out all of the wooden blocks and then stop. We don't dig out the leaves, we just dig out the wooden blocks. Well, why don't we tell the turtle to do that? Well, that is kind of complicated. Basically, you have to tell the turtle to basically compare the block above it to the block that it just chopped. Okay, so after it placed the bone meal and we grew a tree, it dug out the first block of the tree. Well, there we go. We have the first block of the tree that we can work with. Then we go forward, and now we have the first block of the tree in slot number 3, and the same kind of block directly above it. Well, we can compare the two, specifically with the turtle.compareUp function. Now to do that, we have to select slot number 3, because if you remember, at this point in time, we have our saplings in slot number 1, our bone meal in slot number 2, and 1 log in slot number 3. So we go turtle.select 3, and then from here is where we would start the loop. Okay, because before now, everything was we run it once per tree. We would select number 1 to plant the tree, then we would select number 2 to place the bone meal, then we would dig forward, and then we would go forward. That all happens just once every time we make the tree. And then from here, everything we do is going to be repeated an unknown number of times. So we need a loop. And we do the loop in 3 different ways. We have the repeat loop, which will repeat a certain set of functions until a certain condition is met. We have the for loop, which will repeat a certain set of functions for a specific number of times. And then we have the while loop, which while a certain condition is met, it will repeat a certain set of functions. Now that sounds like a lot like the repeat function, but the difference between repeat and while is the condition check happens at the end of repeat. So if you use repeat, it will run through one iteration and then check if the condition is met, whereas while will check if the condition is met and then run the loop. Well, that's exactly what we need. We need to check if the condition is met, and then we need to run our loop. Specifically, we need to check if the block above us is the same as the block in our inventory. And then we can dig up. So let's use that. While, and then from here the command is turtle.compareUp, as I said. Turtle.compareUp. Now for compare up, we have what's called camel case. Basically the first letter of the second word is capitalized. Everything inside of Lua is case sensitive. You'll notice that all of the stuff up here is lowercase and all the stuff here is lowercase up until we get to the word up. And that is because it is 2 words without a space, and they use the capital letter to distinguish between the 2 words. Now that's just syntax. Syntax can be Googled. So anything in here that you're confused about, you're not quite sure about the syntax can be Googled easily enough. That is a surprising amount of the actual typing in coding is Googling the syntax. Everything that is a programmer is all in the thought process of how to make the programs. That's the hard part. So we got while turtle.compareUps equals true. So that's while the block above us is the same as the block in our inventory, then we do. Okay, so this is the first line of the while statement. So while turtle.compareUp equals true. Now, you might be asking, why are there 2 equals there? That's because in programming, the program itself likes to keep track of which is a comparative equal sign and which is a setting equal sign. So there are comparing 2 situations, like, does this equal that? Is this the same as that? and that is the 2 equals. Whereas if you have a variable, which we'll get into later on in the program, and we're setting it to a specific condition, that is 1 equal. So try to keep track of those, because the program is not smart enough to know which one you meant. You have to make sure to tell it which one you meant. And it can cause errors if you slip up. So while turtle.compare up equals true, do the following. We want turtle.dig up and turtle.up. Now this will make the turtle dig the block up above it as long as this condition is met, and then it will move up, and then we end our loop, because that's all we need it to do. So while turtle.compare up equals true, it will repeat the dig up and moving up. So let's test that. We save it, and then we exit. We make sure our trees are in slot number 1, and our bone meal is in slot number 2, and then we type in our tree program. And we can see that it has stopped before it cut through the leaves. So that will make life easy for us. But now we see that the turtle, that's it. The turtle has stopped. The program has run its course. Well, from this point, if we want to make it do it again, we have to go up, dig out the turtle, reset it manually, reset its inventory, and then do it again. Well, we don't have to. We can create another loop to make it come back down. And the easiest way to do that is to make the turtle keep track of how many times it's gone up. Now, it doesn't do that automatically. We have to tell it to do that. Because, as I said before, turtles are relatively stupid. So we edit our tree program. Now, anything you want the program itself to remember, we have to put into a variable. And we declare our variables at the top of the program. Not because we have to, but because that's just traditional, I guess you could say. So, local, and we will call this dist, short for distance. And then we will set it initially to 1. Now, here's what I was talking about the single equal sign. We are setting a variable to equal 1. So now this variable is holding the value of 1. And that's where the single equal sign comes up. We're not comparing the two. We're setting the 1. Then we go down to the bottom here, and we'll create another loop. Now, out of the 3 loops we had, the repeat, the for, and the while, the for will be the best for this situation. So, because we want the for loop to repeat a specific set number of times, and that specific set number of times will be the dist variable. So how we write this is for, calling it a for loop, and then we set its own little internal variable, which just out of sheer force of habit I call I. You don't have to call it I. It's a variable. You can call it pretty much whatever you want. And we set its initial value to 1. And then we hit comma to tell the for loop to distinguish between the initial value of I and the ending value of dist. So every time the for loop will increment, it will automatically increment I itself. We don't have to tell it to increment it. It will increment I itself. And then once I equals dist, it will break the loop. So for I equals 1, comma dist, do, and then turtle dot down. and then end. And then there's one more thing that we need to do to completely reset the turtle. We need to tell it to go back one step. So that way when we plant the next tree, it's in the exact same spot as the previous tree. So we do turtle.back, and it will back up one block. Now, so we have the for loop all set up and ready to go, but we still haven't told the turtle how to keep track of how many times it's gone up. We've gave it the pieces, but it doesn't know that they're the pieces to the puzzle. So we have to tell it that they're the pieces to the puzzle by saying in the while loop, so every time turtle.up is run, it will next run the command dist equals, again, we're setting a variable, not comparing a variable, so it's just one equal sign, dist equals dist plus 1. Now this is how you will increment the variable. So the first time this command runs, dist will end up equaling 2. Now this might be a little confusing. I felt the same when I first learned this. How can we set a variable to equal itself plus 1? I mean, it sounds like one of those math hypotheticals. Infinity equals infinity plus 1. It just doesn't sound right. But with programming, dist, the new dist, will equal the old dist plus 1. And that's how it's done. So this dist will equal what dist used to mean plus 1. Okay, I can still see how it's a little confusing, but trust me, this is how you increment in Lua. There are other ways to do it in other programs, but this is the only way that I found that works in Lua itself. So now we have a way for the turtle to keep track of how far it goes up, so it can keep track of how far it has to come back down. So if we save this, we exit out, we make sure we have our saplings in slot 1, which we do, and our bone meal in slot 2, and we run our tree program. Tree, plants the tree, grows it, digs it out, and then once it reaches the top, it comes back down and backs up. So now we can run our tree program again, and it does exactly the same thing as it did the first time. So I hope you learned a lot from this episode. I know that was a lot to absorb all at once. That is why I'm not going to continue with setting up how many iterations it can go through, setting up which direction it can dump its inventory from, or anything like that. I will let you guys absorb the information you have, and we will come back and look at a different set of programs in the future. Now, if you want the fancy tree program that I created, the link to Pastebin, the link to it on Pastebin will be in the description, so don't hesitate to download it. It works. I've been testing it, but if you notice any problems, don't hesitate to let me know. And if you have an idea for a program that you would like to see me show you how to create, let me know the details of the program, and I will do that. So, I will say, I hope you see you in the next episode, and as always, keep playing the game, and have fun.